Now we come to introductions to second order differential equations. So in second order differential equations, we will learn two types of the equations. The first type is the homogeneous equations. That is, you have the equation equal to 0. Okay, so for instance, you have this one. So this equation is equal to 0. Okay, but if we recall what you have learned in the previous topic, okay, we also have the homogeneous equations, but that is the homogeneous equation in the first order. Okay, so they are having the same name. Okay, you have the homogeneous in first order, and you also have homogeneous in second order. Okay, but for the homogeneous in the first order, they have to satisfy these conditions. Okay, and the example for the homogeneous in the first order, you can have this one and you can have this one. Okay, the detail about the homogeneous in the first order, you can refer to the previous video. Okay, let's just back to this second order and the homogeneous equations. Okay, so we know that this is the first time we're going to learn in the second order. And the second time that you're going to learn in the second order differential equations is something called non-homogeneous. The non-homogeneous means that you have the equations equal to some functions. So for instance, you have this one, okay, this equation is equal to -3. Okay, this is not 0. And next you have this one. Okay, so you have the equations equal to 6x. 6x is not 0. So once you have known what is the homogeneous, homogeneous is equal to 0, and non-homogeneous is equal to some functions, then the next thing that you have to know is, okay, let's just, okay, look at these differential equations. Let's say you have these differential equations, okay, and then you have some extra information, that is this one. And this extra information is basically called as initial conditions. So you have initial conditions y0 and you have y prime 0. Okay, when you have differential equations together with the initial conditions, we call it as initial value problem. Now let's just go to some basic idea of solving second order differential equations. So if we are talking about homogeneous equations, basically you just have to solve it and get the general solution y. But for non-homogeneous equations, okay, you have to split it into two. First of all is you have to let this non-homogeneous, you have to convert this non-homogeneous into homogeneous. And you're going to solve this homogeneous by using the technique that you have learned in here. Okay, and we'll solve it and get the solution. But the solution here, we will call it as complementary solutions, or we call it as YC. And then, okay, only we look at the function f. Okay, the function f here will help us to figure out what is the solution for the yp. Okay, so you need to solve this one and get your particular solution yp. And then, okay, you will combine the solutions that you get from the homogeneous and here, and you get your general solution. So your general solution is the result of yc plus with yp.